Hi, this video is about making sense of Newton's third law of motion. And we start by talking about forces. Forces are not just actions, but they are interactions. A force is always a part of a pair of mutual actions that also involves another force. In other words, forces always come in pairs that act simultaneously. For example, if you clap your hands, your right hand makes contact with your left hand and applies a force to it, but your left hand also applies a force to your right hand at the same time, stopping it. So clapping your hands, we have two forces acting on two different hands. Same example is true if you hit a wall. So when you hit a wall, it's just like clapping. Your hand applies a force to the wall, but the wall applies a force to your hand. So every time there's a force, there's always some other force that comes with it simultaneously. Slapping a disrespectful student's face gently is a great example of just applying a force to a face and the face also applying a force to your hand to stop it. And then lastly, catching a ball. When you catch a ball, you have to slow the ball down, apply a force to it. At the same time, the ball applies a force to your hand. And so forces always come in pairs that act simultaneously. So this is known as Newton's third law. And here it is in a more familiar way. I'm sure you've heard this before. Every force results in an equal and opposite force. You can substitute the word force for action here, action and reaction. Every action has an equal and opposite reaction. That's probably what you've heard before. We say they're equal in magnitude, that is, the amount of the forces are equal, and they're opposite in direction. So equal in magnitude, opposite in direction. If you wanted to write this mathematically instead of in English, you can translate this to a math equation by saying the force vector of object A on object B, so there's a force from object A to object B, it is the same as the opposite direction of the force of object B back onto object A. So to see some examples of that, let's say you're trying to push open a door. You're object A, the door is object B. So you, A, apply a force onto B. So the force of A onto B is equal in magnitude, but opposite in direction of the force that B applies to object A. The door pushes back on you with an equal amount of force, just in the opposite direction. You kick a ball. All right, you apply a force to the ball. Again, you are object A, the ball is object B. So there's a force applied to the ball, A on B. The ball also supplies a force to your foot, slowing it down. And that is an equal amount of force, but in the opposite direction. So they're equal in amount or magnitude, but they're opposite in direction. So it becomes a little confusing sometimes to figure out what is the reaction force in different situations. So I'll try to make it clear to you here. The reaction force is not about how an object responds to being pushed or pulled. So let's say you kick a ball, and then the reaction of the ball is not to move forward. That's not what we're talking about when we say the reaction force. The reaction force is simply the original force, but reversed. So you kick the ball kicks you or pushes back on your foot, right? You push the door pushes back on you. Here's some examples of actions and reactions. Let's say Alan pushes the wall. The reaction force to that is the wall pushes Alan. So we just switch the two objects so that the opposite is happening. A good example is swimming. A swimmer pushes water to the left. So you're swimming and pushing water, as you swim, you're pushing it to the left in this case. The water pushes the swimmer to the right. So you push the water to the left, the water pushes you to the right, and you move forward. A runner's shoes push the ground to the right. You've got to have good traction to be, walking or running. And so when you're walking or running, you push your shoes against the ground. So your shoes are pushing against the ground. The reaction is the ground pushes the shoes to the left. So the ground pushes back on the shoes. And then another one that's maybe a little unexpected, but it should make sense, right? The earth pulls the moon towards the earth. But it's also true that the moon pulls the earth toward the moon. Sorry, I guess I erased it a little bit when I was moving it around. But the opposite force always happens as well. And the tricky part about it is they are equal in magnitude. So the earth pulls on the moon with an equal amount of force that the moon pulls back on the earth. So I wanted to end this video with a question that I want you to think through, because if you're not thinking, then you're not learning. So think about this. This is an area of confusion a lot of times when it comes to thinking about forces and their reaction forces. If the forces are always equal and opposite in every interaction, why don't they just cancel each other out? If they're equal and opposite, don't they just cancel out? If you push on a door and it pushes back on you with an equal amount of force, but in the opposite direction, why don't those two forces just cancel each other out and then nothing happens? Shouldn't that happen all the time then? So I'll leave you to think about that, and you can check out my next video to see a response to this question. So that's all I've got for you in this video. Remember, confusion is the sweat of learning.